Hello and welcome to another of the Nautical Institute's technical webinars. My name is David Petraco and I'm here in London with the Nautical Institute headquarters staff, and I'm being joined today by Charlie from just outside Melbourne at a very late night. Good morning, Charlie. It's midnight. And Carlos from his home in San Diego. So good early morning, Charlie. Carlos, thanks for joining us. Before we get into it, I hope that most of you are familiar with the Nautical Institute, but if you're not, we are an international professional body, and our main role is to assist our members with professional development. And we do that by sharing information, learning from each other. We represent our members at a different forum around the world. We have a seat at the IMO. And it's that sharing of information that helps us develop and promote best practice. And the reason we do that is that we believe that people who are well educated and have the right knowledge make better decisions. Now, that might be a better decision about safety. It might be a better decision about a commercial operation, or it could be a better decision about your career and your own progression. So, but that's what we're interested in. And obviously, positioning, dynamic positioning, satellite systems are really important for our members to understand. So this is why we're holding this webinar. At the Nautical Institute, we've been working with DP for quite a while. Charlie, you probably know better than I do, but it's at least 30 years. And we've worked with the industry. And this is how we know Charlie. We've worked with the industry to develop a practice, a standard for training in DP. We then go on to accredit that training around the world to training centers. And we do the certification of probably around 30,000 DP operators who hold the logbooks. So that's our role in DP. Before we get into the presentation, this is an interactive session. You'll see in the upper right-hand corner of your screen, you have a control panel that you can contract or expand. Once it's expanded, you'll see that there's a place to type questions. Please feel free to type questions in at any time during the presentation. In fact, it's better to ask a question during the presentation because I can spend more time looking at it. Please keep your questions as concise as possible. There are a lot of you out there. There are also some really interesting handouts that you can download. There is going to be a lot of information in the slides that we present. So if you want a copy of those, feel free to download them. We'll also talk about a book that we do called the DP Operator's Handbook. And one of those downloads is the first two introduction chapters that has a lot of good information in it about DP systems and how DP works. So you're more than welcome to those. After the webinar, there will be a little pop-up survey. It only takes 2 to 3 minutes, but would appreciate it if you took the time just to tell us how we did and what we can do better. About 2 or 3 hours after the webinar, you'll get a thank you email saying thank you for attending, and there will be a link to a personalized certificate in there, and feel free to download that if you would like. This is being recorded, and the recording will be posted on our YouTube channel probably by tomorrow evening. So just have a look at that. You go on YouTube, type in the Nautical Institute, and you should find us fairly easily. You are not alone. There's a lot of people out there, nearly 900 today. So please, if you send in a question, keep it concise so we can get to as many as possible. What we're looking at is probably about a 30-minute presentation followed by Q&A up till the top of the next hour. So it is my pleasure to introduce our speakers. We have Captain Charles Stuart, Associate Fellow of the Nautical Institute, a master with many years of experience in command, lots of experience in the DP sector, and he's currently an advisor to Tidewater. And there'll be some more information about that. And we're also very pleased to be joined by Carlos Hernandez from Wärtsilä. Again, huge amount of experience in DP and the technical side of things. And Carlos, thank you so much for coming and sharing some of your technical expertise with us.
Yeah, thank you.
With all that said, I'm going to hand the con to Charlie.
Okay, welcome everyone. We were asked to give a presentation on DP by the Nautical Institute. So I'm giving this presentation on behalf of the Tidewater DP Excellence Committee, a group of DP masters that control safe DP operations within Tidewater. For the webinar, for this one, we've broken it down into a couple of sections. One is for anyone who doesn't have any knowledge about DP. So we'll have a few quick slides about what is a dynamic positioning for those that don't have that much of an idea. So I would ask those that do know about DP just to bear with us for a few slides. Then we'll get into the main part of it, which is anyone interested in stopping DP incidents from jamming and spoofing of GNSS systems. This pertains to all DP vessels, whether it's in the offshore industry, whether it's in the wind farm, passenger vessels. Anything fitted with DP, it relates to the position reference systems that we're going to talk about. The topics today will be what is a DP vessel, the main elements of the DP system, an overview of some position reference systems, and what is GNSS jamming and how does it affect DP vessels, and spoofing and how does it affect DP vessels. And we'll cover how to stop all risk involved with jamming and spoofing at no cost by the correct use of position reference systems. And at the end, we have 5 slides from Wärtsilä on their excellent position reference handling software in their system. Basic concept about DP. A non-DP vessel, you would have a deck officer driving the vessel by moving the handles to control the propellers and thrusters, the whole position of the ship. On a DP vessel, we have DP computers that actually send the commands to the propellers and thrusters to hold the ship in position. In the DP world, we call propellers and thrusters thrusters. So I'll refer to them all as thrusters. We won't discuss in this webinar class 1, 2, 3 or redundancy because the position reference systems does pertain to all DP vessels. The main elements. The main computer that controls the ship and calculates is called the DP controller, not the operator station that's normally on the bridge, and it calculates the thrust commands required to hold the ship in the vessel, hold the vessel in position. DP controllers are only fitted to DP vessels. We have a DP operator. DP operator is there to issue commands to the DP system on where to move the ship and to oversee the operations of the vessel. The DP operator talks to the DP controller, the main DP computer, via the operator panel, operator console, and enters the commands through there. Again, the operator panel is only on DP vessels. To hold the ship in position, we need thrusters. So the thrusters are connected to the DP controller by the REO interfaces, and they're the same on all vessels, non-DP vessels or DP vessels, and you need some sort of thrust to hold it there. To drive the propellers, we need a power system, and they can either be direct drive or electric generators, and the power generation system pertains to the switchboards, UPSs, diesel generators, and that would be the same on a non-DP vessel or a normal or a DP vessel. The DP system can't look out the windows or anything like that, so we have to give it a gyro input so it knows which way the heading of the ship is and if the heading's changing, and that's the same on all vessels. We need to tell the DP controller whereabouts the ship is, so we feed in position reference data from position reference systems which will be the main crux of this webinar very shortly. On top of all those items I've mentioned, we need to feed in the wind and the roll and the wind speed direction, so the DP system can calculate the effects of the pitch, roll and wind. So that was a brief overview about the DP system and the major components and the difference between a non-DP vessel and a DP vessel. Now let's talk about some of the position reference systems. On the left-hand side there, we have a differential global navigation satellite system that uses the satellite systems. A laser-based system, which uses a laser to measure the range and bearing between the platform and the vessel. And a microwave radar sensor, which uses a radar-based signal to measure the range and bearing to the platform. Now, this is only 3. There's many other position references, but for this webinar, we'll keep it short and we'll just concentrate on these 3 systems. Global navigation satellite systems. There's 4 main satellite systems. There's the American GPS, the Russian GLONASS, European Galileo, and the Chinese BeiDou. All 4 systems work on slightly different frequencies and they have different orbit patterns for their satellites. There's also an Indian system, a local Indian system, and a Chinese system. On the right-hand side of the screen, you'll see a screenshot of a Fugro Seastar 9200, and it's operating with GPS, GLONASS, Galileo, BeiDou, and operating G4 corrections. So you can see by using all 4 satellite systems, you get a lot more satellites up there, and the more satellites you use, the better. The term differential or DGNSS, differential is standard GNSS system positioning with additional corrections added to it to give you a very accurate position for DP operations, i.e. from the picture there, the Seastar 9205 accuracy is can be between 10 to 20 centimeters. So fairly accurate and fairly stable. The more stable you get the positioning system, the easier it is. Let's get into the crux of this webinar, and that is the jamming or interference affecting DP vessels. Jamming is described as a high power signal, multiple frequencies, that has the potential to block all satellite communications. It can come from a hostile source or someone trying to stop the use of GNSS in their area for protection for some reason. Jamming can block all the satellite systems, or it can just block the corrections that stabilize the system. The effects of jamming is that it causes a loss of the position, the DGNS system, position data into the DP system. So if you get hit by a jamming signal, it just stops the feed into the DP system. The list here is what also can stop the feed into the DP system from a position reference sensor. So we can have internal, external jamming or interference. We can have blocking of the correction satellite signal. We can have a problem with the hardware of the DGNS unit. We can have problems with the antenna cabling. We can have sunspot activity, blocking the satellite systems, scintillation. You can block the correction signal with a crane operations. The DPO can deselect the position reference system, the DGNS, from the DP system. That will stop the feed into it. And interference on board, like placing equipment, the TV antennas, satellite communications dishes near the DGNS antennas, and the incorrect installation of the DGNS equipment. So what's listed above all have the same effect. They stop the position data from being fed into the DP system. So With the correct use of the position reference systems, we can stop the effect of jamming, and it doesn't cost us any money involved or any extra equipment, just the way we operate our DP vessels. A little bit of theory about how the DP system uses position reference systems. Now, I need to say that it's very important that we use at least 3 position reference systems using 3 different principles selected into the DP at all times. Most DP vessels will blend the position reference data from all the position references to get a blended position on the center of the screen. Jamming will cause the loss of the DGNS feed into the DP system. It's important that we have the medium alarm, which is a rejection alarm, and on some systems, warning and reject selected. And at this stage, and I'll repeat it many times, it is very important for the DPO to keep the position references calibrated to within 3 meters of the blended position, and closer if possible. So what happens when you get a jamming event or a loss of a position reference system? You have a loss of the feed of data into the DP system. So the DP system loses that, so it no longer uses the 3 position references for calculating the blended position. It uses the 2 that's left over. So the vessel moves to a position between the 2 sensors. What happens if the DPO allows the position reference systems to drift apart? The DP still holds the position in the center or the blended position, and the spread of fixes can be between 3 and 11 meters, depending on the DP system. Then if you have a stop of data, position data for any reason, or a jamming event, then the data from the differential will be lost. Because of the spread of the fixes was quite large, the vessel can have a fairly large movement of position or drive off. And quite often you'll say, and the down there in the red is that the loss of position was not caused by the jamming event. The loss of position was caused by the systems not being calibrated. So again, very important to keep the systems calibrated to the center of the screen, and you can migrate the effect of the jamming event. Spoofing. What is spoofing? Spoofing is when someone modifies the GNSS satellite signal or the correction signal and appears a false position is outputted from the system. So spoofing can cause the DGNS to output the wrong position into the DP system. The position can jump, can move slowly, or it can move fast. Like jamming, spoofing can be, the effects of spoofing and the wrong output can be from other sources as well. So the sources that can cause the wrong position data to be fed into the DP system is is spoofing. Some interference on board the DP vessel will cause small movements. Relative reference systems like lasers and microwaves, when the targets are mounted on a DP vessel FPSO and they move, they can cause position reference. They can cause the wrong position data to be fed into the DP system. Laser systems can lock onto overalls and again cause a false target of moving. We can have the incorrect position reference, the offsets incorrect in the DP system. So if you move the vessel or change the heading, then you have a spread of position because of the wrong data being fed into the controller. And you can have an internal slow drift of the sensors in the DP system, which is natural, and they slowly drift apart over time. So all these have the same effect as spoofing, incorrect position data being fed into the DP system. The correct use of the position reference system can stop the effect of spoofing and incorrect position data at no extra cost. Here's some examples of some spoofing events. We go back to the 3 position reference sensors, and it's important to have 3 position reference sensors on 3 different principles selected in and calibrated into the DP system. And again, make sure that they're within 3 meters, preferably 1 meter. And as you can see by the red, the green, the row of green crosses, if a spoofing event affects your differential GNSS and it slowly drifts out, it will, when it gets to the edge of the rejection circle, it will be rejected. Once it's rejected, again, the vessel takes up the position between the last 2. So again, very important for the DPO to keep the position references calibrated within 3 meters. And as I said, better to within 1 meter. And the use of 3 position reference sensors on 3 different principles. The problem that occurs when we use 2 differential systems and 1 relative. A lot of times vessels will use 2 differential systems or 2 satellite systems and a laser system and a microwave. If you use 4, many systems can get a little bit confused with that. So it's best only to use 1 satellite system. But if for some reason they can't get the target to lock on or the reflectors are in the wrong spot, they end up using 2 satellite systems and 1 laser system. If we have a spoofing event, what can happen is that the 2 satellite systems, the DGNS systems, can drift at the same time. They can drift slowly, which is sometimes more of a problem. If they do a big jump, it's normally rejected. But we have a thing in what happens when they move. They have a system in DP systems for voting. So if you have 3 position reference systems, the DP system will vote out the odd one. So if 2 satellite systems drift because of spoofing, then it will reject the good sensor and the vessel will have a drive off. So again, repeated, 3 different position reference sensors selected using 3 different principles, and only use 1 DGNS system at the time. And of course, the DP operator needs to keep them calibrated within 3 meters. Okay, takeaways from this webinar. I've made it nice and quick because the lesson learnt from this is an important one. Jamming and spoofing affects DP vessels the same as many other issues with the DP system. So for safe DP operations, the DPO should always monitor the position reference page. If you've got the position reference page open, you can see what's happening before anything goes wrong, and you can see that they're kept well calibrated. The second important thing is that the DPO keeps all position references calibrated within 3 meters of the blended position, and better if they can keep it within 1 meter. Use a minimum of 3 position reference sensors on 3 different principles. Only use 1 DGNS when closer than 100 meters to a work site. Coming up to a work site, 2's fine, but when you get to an area where you can pick up your other relative systems, it could be HPR, could be acoustic systems, could be a laser, microwaves. Risk from DGNS jamming and spoofing can be avoided by good operating procedures at no cost today. Doesn't need extra equipment or anything else. It purely comes down to good operating procedures, and you can do that straight away. Quite often I do see a lot of ASOGs from charterers and a lot of people using 2 differentials, but that does leave us open for spoofing events in the future. The final comments I would make for this is, it doesn't matter how, if the jamming signal is very strong, you will never stop the jamming. You will lose that feed into the DP system. So you need to allow and plan for that. There is many new systems that can lower the risk of spoofing. And there's a lot of new software and anti-spoofing computers coming out to fit into DGNS systems. But the key for safe DP operations is the correct use of the position reference systems by avoiding common mode failure. So common mode failure by using two differentials. The next couple of slides is we'll move on to the position reference system from Wärtsilä, and I'll run the slides and Carlos will just talk over the top. So you can take it away, Carlos.
Thank you, Charlie. As we see from Charlie's summary, GNSS jamming and spoofing cannot be stopped, but we makers of DP systems can improve our products to grow with the needs of the industry and the continual change that we all experience. For Wärtsilä DP, we worked with Captain Charlie's inputs along with our experiences with the DP to develop a solution to minimize the impact of these sudden shifts in sensor data. Next slide, please. So here we see the available and selected sensors are DGPS-1, side scan, and radar scan. So you see the little dots in the middle of the screen there on the overview page. So how do position systems or reference systems drift? One example, a drifting radar scan can be induced by the target actually being moved on board the platform. Another example of drifting data or drifting sensor is the amount of drift that accumulates over time. This could be caused by incorrect antenna offsets for the DGPS system or incorrect offsets in the DP. So as the vessel heading keeps changing, the drift will accumulate and you'll see the sensor start to spread on your overview page. Next slide, please. So in a situation where the online position sensors have drifted apart, where we see here on the left-hand side, you see the three tokens in the middle of the vessel there are moving away from each other. In that scenario, hitting a calibration button may cause a noticeable shift in the vessel's estimated position, causing the vessel to move, which is not what you want, especially close to another installation. So to simplify the operation of this, Wärtsilä implemented a one-button calibration system, which eliminates the need to deselect any of the position reference sensors that need to be calibrated. In this case, when enabling the calibrate to blended function, there will not be any movement since all the sensors, including the origin or reference sensor, will be calibrated to the blended position as we see on the right-hand side there. Next slide, please. Now, what happens when a position reference sensor has a huge change in the data, right? So it's being spoofed or something like that. In order to reject the position reference sensor, the operator needs to set what we call a median test alarm. And that basically is any position reference sensor that moves outside of the circle, as we see in the center there. The DGPS-1 has jumped significantly. That will trigger an alarm. And on the lower left-hand page, you see DGPS-1 median test alarm. So now the DP system has sensed the sensor has jumped, and now the DP will alert the operator and then take action, right, to mitigate the movement. Next slide, please. So how does that rejection work? There has to be, as Charlie mentioned, at least 3 position sensors online and available in order for the DP to be able to detect the fault. So an example here, we have 2 DGPSs and a relative sensor. When the 2 DGPSs are affected by interference or spoofing, the DP will mitigate the drive off by starting a controlled move to the blended position. Since this is a controlled move and not a sudden move, the operator can assess the situation and click the current position button to stop the move and maintain the vessel at the current position. It's a very simple way to maintain control of the situation. All right.
Back to you, David.
Thanks very much, Charlie. And Carlos. Let me just take the column back. Right, so we've got plenty of questions here, so hope you're both ready. But just before we get into it, I'd just like to say on behalf of the Nautical Institute, we're very pleased that Charlie and Carlos have been able to share some of their experiences with us, because it's all about sharing and learning together. However, there have been a lot of product names mentioned. There are other companies and there are other products out there. So the message is not necessarily to go after the product. The message is to be aware of the situation, and then you make your own decisions. So Charlie, one of the questions is, with DP, why is it so important to have that few meters accuracy on a ship when you might be doing something else? What are the operations that require that kind of accuracy?
Yeah, most DP vessels fitted with DP are fitted for simply that they need good control at all times. If you're supply work at a platform, then lowering containers down onto a deck and fitting them into position, you don't want the vessel to move around. If you can keep the vessel within a meter, couple of meters, it makes it a lot easier for the crane driver. And the better position data you can get in, so if you get really accurate position reference data, the vessel becomes very stable. And that goes for crane operations. If you're a construction vessel and you're lifting a heavy lift down, all the operations require a high degree of holding the vessel in the same position for a long period of time. And of course, computers don't get tired, and that's why we use the DP systems. And back to you, David.
Okay, thanks very much, Charlie. Got a question here from Mark. It's a few questions, but I'll group them together. The first is jamming illegal? And the second is, if you were going to jam a GNSS signal for, say, up to 3 miles, what size of equipment are you looking at? Are you looking at something that fits in your pocket, or is it on the back of a lorry?
Well, I wouldn't be able to answer that exactly, right? But the simple one is that in most countries, GPS jammers are illegal. It's an interesting that most of the jamming does occur on the GPS frequencies where they're so close together. At the moment, some companies are reporting to me that there's not much interference with other systems. So GLONASS, Galileos, if you have a mixture of those, you don't have so much of a problem. Again, it just depends on the transmitter at the size. It's not going to take you a very big thing to transmit a frequency on that band. So you just need to transmit a lot.
Okay, thanks, Charlie. We've got a question here from Gordon. It says interoperability between differing GNSS constellations. Is that better or worse in regards to spoofing and jamming protection?
Okay, so this leads on from the other one. Most of the jamming and spoofing we're seeing is in the GPS frequencies. So if you add GLONASS to it, a lot of the DGNS systems won't fall over. They'll lose the GPS position, but not the GLONASS. So if you then add Galileo and BeiDou and have 4 satellite systems being fed into the processor, then you help greatly to avoid the spoofing and the jamming. Of course, spoofing, if you have to do it, if you use more different frequencies or more different satellite systems, it's going to be harder and harder to do the spoofing.
Okay, thank you. Carlos, do you have anything to add to that?
Yeah, I mean, in my experience working with DP operators closely over the years, it's recommended to have a DGPS or GNS system that uses multiple satellite constellations at the same time. So your C-Star 9200s and those that you can then have as many satellites as possible. Instead of just having 8 or 9 satellites, you can have up to 20. And the more satellites you have, the better the DP positioning can be over time. So for sure, multiple satellites is the key, or multiple systems.
Okay, and we got a question here asking about are multi-system receivers available commercially?
Oh yeah. For sure. Fugro, Furuno, they all have them.
Okay, and can they be fitted on vessels that aren't DP?
Oh yeah.
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 Okay. We've got a question here, fairly specific. Dear Captain Stuart, would you please share your thoughts and recommendations about ROV operations at 1,500-meter depth in terms of DGPS jamming, especially when in follow target mode? And that's Vladimir who's asked that.
1,500 meters is quite a deep operation. What I would say about that is we do have procedures. I've put procedures in place before for this. When you're doing ROV operations and follow target mode, you're using the differential DGPS system, DGNS systems to hold the vessel in position. So if you have a major jamming event, which can be quite severe, we've had some big jamming events in the Mediterranean where you lose all your equipment. Then you have a problem that the vessel does not have any position reference data going into the DP system. So we put a procedure in place that we have the ROV sit down on the seabed, change the beacon to fixed, to lock onto that until the jamming comes, this jamming leaves. What we have seen in the past, jamming doesn't last for that long. There hasn't been big malicious attacks that last for a couple of hours. For 1,500 meters, you're probably doing a drift recovery and launch. So you can put the unit down on the seabed. It's a little bit down, but you're going to have a big footprint at that depth anyway. Be safe. Once you've stabilized, you can just recover the equipment on a drift recovery quite easily without any position reference sensors.
Okay, thank you. We've got a question here from Ison. We have been taught that if we use two GNSS systems using different systems, example GPS and GLONASS, then it is considered as using different reference systems. Is that true?
The general thought is that as long as you're using two satellite systems, there's a common mode failure. Jamming, of course, is one of them. So because it's a common mode failure, most charterers and most people will not recognize two differential systems as single references. So, and as we're getting more and more jamming and spoofing, then obviously this should not be done. So no, it should be as same. It has the same common failure mode. So no, it should only be classified as one system.
Okay, thank you. Carlos, I think this one's for you. Again, very technical from Hamuz. How does the Wärtsilä DP system detect jamming in respect of continuous wave, swept CW, pulsed CW? Does the Wärtsilä DP system incorporate a time and frequency synchronization platform?
Yeah, it's not so. We're not able to detect any sort of jamming. We're looking at the actual DGPS data and we're comparing one cycle to the last. So every time we get a new piece of data, we look at it and we say, okay, how far has it moved? Go through some noise reduction logic and some other testing internally. And then we determine that the sensor data is valid and continue using it. If it's not valid, the sensor is rejected. And invalid meaning that it has moved quite significantly, or if there's a failure of the data itself, then the serial string just stops updating. So based on that, then we use the data or reject it and give the operator the opportunity to either select a new sensor or deselect a sensor that is faulty to investigate. So there's not much you can do to detect the jamming, but you can definitely monitor the data.
Okay, thanks, Carlos. Charlie, you mentioned that there's an increase in jamming and spoofing. Lazar asks, is there any noticeable increase in jamming and spoofing in different places around the world?
Yeah, I do have the benefit of getting access to a large global fleet of information. So normally in Tidewater fleet, if there's a problem with a position reference system, our main email is notified of that. So we do monitor those areas. We pass that information back to Frugro. The Americans track American government military track jamming events. What I would say is it's not great problem. It's not increasing very fast. Because I do all the investigations for DP incidents and looking at problems with DGNS. I've got a project at the moment that covers all DGPS units on DGNS units on all ships in our fleet. At least 95, 98% of all problems are internal setup problems. They're not jamming and spoofing. We have rarely see a jamming and spoofing event that affects our operations. If you have 3 position references, it will never affect you. It's very easy to detect because the DGNS systems are fed from different UPSs, different antenna systems. If you lose both position references, both of the DGPS units go off the air at the same time, then you can point towards a jamming event, because you can't. It's very rare that you can actually have all systems, all your satellite systems fail at exactly the same time because they're isolated systems.
Okay. Just to add on to that, the good housekeeping, like Charlie mentioned there, a lot of the problems are generated on board. Installing the DGPS antennas properly, meaning have enough separation distance between them, is recommended by the manufacturers. And also, as charters change, new equipment gets installed on board. So we've seen where some ship-to-shore transmitter was installed below the DGPS receivers, and so then, or the antennas. So then whenever a transmission to shore was enabled, a cone of radio waves would go out and block out all DGPS corrections. So the vessel would lose DGPS corrections at least twice a day. And it took some time to figure that out, because it was sort of like, well, it keeps happening even though nobody's doing anything. And it turned out it was a transmitter that was installed on board. So definitely keep an eye out for things that could have been done on board that could cause new issues.
Thanks, Carlos. Sasha asks, is there a limit on the number of position sensors? Why only limit to just 3?
Okay. So I'll answer a little bit of this and then I'll throw it across to Carlos. I used 3 in this presentation to demonstrate what happens. I know that if you use 4 sensors, they can start rejecting each other. You can do simple tests by putting fixed relative systems on your ship and moving the ship and watching what happens. So there's lots of things you can do on board the ship to test these if you have the time. There's no limit. I'll throw this back to Carlos, but you can put a lot of position reference sensors in. The more, the better. But if you're going to, you've got to outnumber. So if you put 2 differential systems in, you've got to well and truly outnumber it with other types of position reference sensors. But if you've got a lot of position reference sensors, we only need to put the 1 differential into the system. And it just depends. When it comes to the number of position reference sensors, it's mainly to do with the DP software and how many inputs have been actually set up at the time. Back over to you, Carlos.
Yeah, basically, when we're looking at the number of sensors required by class, that's one thing. And then there's the number of sensors that are required by the operation. So, class's main directive is you have to have at least 3 sensors, right, in order to enable fault detection. And then on top of that, they recommend that the 3 sensors are of different technologies in order to avoid any sort of common mode failures like Charlie mentioned earlier. So that's the main 2 things. Then you come to space. How much room do you have on board for different technologies like a taut wire, underwater acoustic system, the ability to deploy beacons if you needed it, or you're working in water that's so shallow that beacons do not work, underwater beacons. So there's a lot of variables there. And then also there's regional issues too, like, down in the equator when you have scintillation, well, then you have to turn off your DGPSs and use acoustics and those kind of systems. So it really comes down to the operation and what you're trying to achieve in terms of vessel stability. That's what really drives the position reference selection.
Thanks, Carlos. Got a question here from Mario. Any advice on how to mitigate jamming or spoofing on DP systems used on cruise ships, where DGPS is the most common DGNSS? So cruise ship applications where GPS is the most common system.
It would help if we had a bit more time to think about these ones. Okay, yeah, look, okay, so every situation can be thought out. So if you've only got DGNS, then you've got to risk assess what the risk of losing position is. So are you going to hit a platform? Are you going to cause a major oil spill? Are you going to kill someone? These are your risks. If you've only got DGNS, what can be done? Well, you can put one system one end of the ship, and then you can put another system at the other end. Therefore, that you isolate on board jamming. A cruise ship, you would fit satellite systems that have all four: GLONASS, GPS, Galileo, and BEDU at each end. You could look at that stage. You can look at there's lots of other systems we never mentioned because we only had half an hour. So the big one is INS, inertia navigation systems. So you would fit an INS system so that you know that if the position data coming from the satellite system was moving, but the ship physically wasn't moving, then you could go into that. So there's lots of add-ons in this situation, but they're expensive for the normal smaller ones, but for a cruise ship, then the cost will be well worth using inertia navigation into the DP system. Carlos is, yeah, okay.
Yeah, I think for cruise ships in particular, they're typically the navigation systems are simple GPSs, not like the ones we're used to on the workboat, right? So navigation GPS versus a positioning GPS is one of the issues there. You can definitely have a higher level BGPS system like a Fugro 9205 and be able to have more data, like Charlie said there, having more satellites. But also, one of our colleagues here had recommended that maybe what they're talking about here is related to docking, and that you can then use other sensors like relative positioning sensors like radar scan and side scan or scene scan even, to then add more position reference data to the vessel, right? Especially when it comes to the docking scenario.
Okay, thank you both. Questions in from Stanislavs. What is the general good practice for positioning of GNSS antennas relative to other transmitting antennas?
Don't put them anywhere near it.
Yeah.
It's the top of the mast is prime real estate. The mast structure, the design of the mast structure is very important. You want a bigger area as possible. And as Carlos said, you need a couple of meters clearance between them. You can't put a satellite system and a high level DGNS system next to each other. So you just got to keep everything as separated as possible. If you've got two masts, and as I said on the cruise ships, if you have one each end, then it makes it a lot easier for doing this. But anything that transmits, big issue I have is TV antennas. Obviously, the crews want the best TV possible, so they'll put the TV antenna up the top of the mast amongst the DGNS system.
Okay, thanks. This is more of a comment than a question. It comes from Matt. And he says, it is apparently common for truck drivers and delivery drivers to use portable jammers to block their own employers' GPS tracking. These handheld systems can sometimes block signals for several kilometers, depending on local conditions, which is a big problem for airports. And I've seen these, on the internet. Somewhere somebody's going to find out that I did some internet searching for jammers, which Mr. Google might get me in the end. And we've heard about this in ports. If one of these jammers is driving along a port or crossing a bridge. And it makes me wonder also, and this is me speaking, not Matt, if there's a risk to car ferries if these jammers are used and a car gets on a car ferry. Have you guys had any experience with this?
What I would say before I hand it over to Carlos is that it doesn't matter what sort of DP system it is or what you're using the position reference data for. The key is the mixture of it and not the reliance on the GNSS system. If a vessel was entering port, we have a lot of vessels run aground because they're relying on the satellite navigation. They lose the technique of using radar, bearing lines and stuff like that. So it's a mixture of position reference data, looking at your eyes, looking at the buoys, bearings, as such as that. So if you're running a car ferry again, you've got your scene scan, you've got your dock masters and stuff like that. Over to you, Carlos.
Yeah, a lot of the area that Wärtsilä's been working in this last year is smart marine, smart docking, using systems like scene scan to be able to bring the vessel in, like a targetless system like scene scan, could then be used to mitigate any errors that you may be receiving from DGPSs or loss of signal. So definitely having a variety of sensors available, and again, application specific is what's going to drive this, right? So you don't need an underwater acoustic system if you're a ferry docking, but you definitely need some sort of other relative positioning system that will help keep the vessel basically operating safely.
Okay, thanks both of you. This question comes in from Rakesh. He's talking about differential implies some sort of position augmentation, say GBAS or SBAS. What is the applicable context here, GBAS or SBAS? And perhaps before you answer that, you can just briefly say what GBAS and SBAS are.
I don't think we need to go too far here. They're just systems to supply corrections to uncorrected GNSS systems. The best ones are the paid correction services, give you the most accurate of them, but they're all the same. They're supplying differential corrections to run on the standard satellite navigation system.
Sorry, just to do a little product placement. If you're interested in that sort of thing, we got a great book that covers it. Right. James asks, when pressing the calibrate to blended button on the Wärtsilä system, is this effectively switching on off the PRS on the desk?
No, not switching it on and off, but it's doing is it's taking, without getting too technical, it's taking all of the data that we have stored for every single position reference sensor and resolving it back to a central position that is basically where the vessel should be, right? So as sensors drift away from each other, that error will continue to grow, and what would happen normally is the DP system would calculate the vessel's position somewhere between those. So as that sensor keeps moving, your blended position keeps moving along with it, because now your median, your center is growing. So the calibrate to blend basically eliminates that error by taking the change data and saying, okay, it's moved 20 meters, so that must mean I'm still in X position. And basically, when you recalibrate, it brings everybody back to the middle, and there is no bump in position with that calibration. So that's how it works. It's literally tracking every single sensor independently and then coming up with a blended position for the vessel.
Okay, thanks, Carlos. Charlie, just back to the generics of DP. If somebody wants to get involved and become a DP operator, how do they go about that?
They follow the Nautical Institute training scheme. Would be one that you should be pushing. There are several schemes out there, but you need to go for one that has sea time. But again, there's a couple of systems out there. Obviously, for Nautical Institute webinar, we'll push the DP operator scheme for the Nautical Institute.
What a good idea, Charlie. What a good idea. Right. Okay. There are lots and lots of questions, but I do have my eye on the time. So just to wrap a few things up. Charlie did mention the DP Operator's Handbook. That is available from our website. Just as a special offer, well, first of all, there's that handout, which is the first couple chapters of this book that give all the basic information about DP, how it works, why it works, et cetera, et cetera. So that's a free handout. You're welcome to it. If you'd like to purchase the book, ignore that price. Give a quote, write to that email address, and you can get a 40% discount from watching this webinar. Don't worry about reaching for a pencil. These slides that I'm using are available for download as well and have all the information on. Also, as Charlie mentioned, we do oversee a number of schemes that are taught by independent training providers all over the world. And if you go onto our website, you can find out where they all are. There are courses in offshore, specific courses for shuttle tankers, jack-up rigs. And Charlie, you've been a great help with us getting this one for the vessel maintainers course off and running, and that'll soon be available out there for those with an engineering background. So feel free to go to that NI Alexis platform for more information, or write to accreditations@nautinst.org. So that's just about it. I would like to remind everybody that first and foremost, the Nautical Institute is a members organization. So feel free to join us as members to continue this type of conversation, so that we share information, so that we share learning amongst ourselves, so that we can all make better decisions. So on that note, Charlie and Carlos, I'd like to thank you so much for your time and helping us in these odd time zones as well. So thank you very much for your efforts in that.
Yeah.
Thank you, David.
Okay, and I will invite Charlie and Carlos, I'll invite you to log off just before I close the system. And I would like to just extend thanks to all those listening for your support, your really interesting questions, and join the Nautical Institute. Thank you very much.
Thank you.
Bye.